interested in doing this question for you, mostly because it's using summation notation. This is exercise 10F2, question 5A that I've chosen. At the end of the question, we'll check that we get the right answer using the calculator. I want to remind you that your calculator can do sums. Right. So they've given us this expression here. If we had a sum, right, we want to know, is this sum equivalent to some sum of a geometric sequence? Right, because if it is, and if the R value lies between -1 and 1, then I could then use, therefore, the infinite geometric series formula, T1 on 1 minus R. Okay? But it's not particularly clear that I've got T1 times R to the power of n minus 1 at the moment. So let's think about it. What would be the first term? It would be k equals 0, right? So if k equals 0, then I've got 3 on 4 to the power of 0. 4 to the power of 0 is 1, so I would have 3. Second term is, I just want to check that. Are they starting at 0 or 1? Oh, I've made a mistake. They've started at 1. My bad. Fix this up. Erase that, turn it into a 1. Okay, so the first term is actually 3/4. Right, so we put our 1 in and we get 3/4. Right, the second term, k will be 2 at that point, so we'll have 3 on 4 squared, which is 3/16. The third term would be 3 on 4 cubed, which is, right. So, okay, I've got my T1, that was easy. Right. Let's see what the R value is. So the R value could be found from T2 divide T1. If I get the same R value when I do T3 divide T2, then presumably I've got a geometric sequence of numbers. So let's do that. 3/16 all divided by 3/4. Well, that's the same as 3/16 times 4 on 3. And we'll get some cancelling. Here, 4, right? So our R value is 1/4. We could check it here as well if we wanted to. And by golly, we want to. Okay, so that's the same as 3 on 64 times 16 on 3. We get cancelling here to leave 1s. We get cancelling here to give 4, 1/4. Right. So I now know that the R value is 1/4. And we could have written this sum slightly differently, because we could have said we've got 3/4 times 1/4 to the n minus 1, right? Okay, let's figure out this sum that goes to infinity using the infinite series formula. It'll be term 1 divided by 1 minus r, which ends up being 1, because you'll have 3/4. How many 3/4? One of them. All right, so that's the answer. Now, I just also want to remind you that on your calculator, if I go to the calculator, what will it look like? Yeah, you should be able to see what I type in. So I'm going to find my sum button using the alpha F2. It is number 2. Instead of K, we're going to use an X. We're going to, maybe if we sum up 50 terms, that's probably more than enough. So obviously I can't sum up to infinity, but I can still check on the calculator. Right? I can just sum up to a high value. Don't make it too high, or else your calculator will be there thinking forever. So I think 50 will do it. Let's find out. And I've just typed in exactly what was in the question. Right. And I'm expecting that this answer will come out to be 1. And it does.